right, so this unit is super short that we're doing. We're starting today, and we're actually testing next Wednesday, so it's just a 1 week kind of unit. Today is all about points of concurrency. That's the main topic, and we look at that in triangles. So you may remember some of these from last year, so I just kind of put them all on the paper for you, but there may be some things that you want to highlight or underline, so you might want to get out, highlighter if you have one. Okay, the first one we have is median. Now, when you think about median, what's the first word that comes to your mind? Middle. Good. The median connects the middle or the midpoint of the opposite side. So, median, middle, midpoint. All of those words kind of go together. All right, and altitude. What do you think about when I say altitude? How high something is, right? How tall it is. Now, the altitude, a key thing with it is it always makes a right angle with that opposite side. But depending on what type of triangle we have, depends on where that altitude is drawn. So if it's an acute triangle, it's going to be drawn on the inside of the triangle. If it's a right triangle, it's going to be the side that has that right angle with it. And then if it's an obtuse triangle, it's actually going to be drawn outside. And we saw a picture of that last week when we talked about the area of a triangle. We had that altitude that was drawn outside. But the key thing about the altitude is it goes from the base and straight up in the air to the height. It's kind of like an airplane flying. We're not going to see how far an airplane is flying diagonally. We're going to go straight up for that altitude. It's that vertical distance from the ground to the top. All right, next we have perpendicular bisector. Well, when you hear the word perpendicular, what should you think about? And something else besides the line? 90 degrees or right angle, yes. So perpendicular bisector forms a right angle, and then bisector does what? Cuts it in half. So your halfway is like your midpoint. This is the only one that does not have to be drawn from the angle. If you notice these other two, they start at a top angle of your triangle or any angle, and then the median's drawn to the midpoint. The altitude makes a right angle. But a perpendicular bisector just goes through here and says, let me find the middle of this side. It's right here, and I'm going to make a right angle. Okay? So it doesn't have to be drawn from an angle. We just find the middle, and then we make a right angle. The last one we're going to focus on is angle bisector. I think that one's pretty self-explanatory. Cuts the angle in half. So we can see the different measurements that you have there. So angle bisector bisects the angle. There's really no other way of saying that. But it cuts that angle into different pieces, different halves. There's a problem at the bottom of your sheets that you're looking at right now. We're going to come back to that problem in just a few minutes. So if you would, turn your piece of paper over. And we have some blanks that we're going to fill in. So a point of concurrency is what we're going to talk about next, and that's where we draw 3 of these lines together. So when we draw 3 medians, 3 altitudes, 3 perpendicular bisectors, and 3 angle bisectors, we get 4 points, and those are our points of concurrency. So it's where those 3 lines concur at the same time, so where they all intersect together. So let's look at our first one here. Our first one is called a centroid. So this dot right here is the centroid of that triangle. Now the centroid is made up of certain kind of points. So if you look at the front, is it made up of the medians, the altitudes, the perpendicular bisectors, or the angle bisectors? Medians, how do you know it's medians? That's right. Thank you. It's where all those lines intersect and we see the halfway points on the sides. So when you look here, this side is cut in half, this side is cut in half, and this side is cut in half. Are all three sides equal to each other? Well, they're not all equal to each other, but they are all cut in half with each other. Okay? So in this first blank, we are going to put it's the intersection of the three medians. Because we can see all the sides are cut in half at the middle. The centroid always falls inside the triangle. So it's always going to be somewhere inside, no matter what type of triangle it is. It could be acute, right, or obtuse, but it's always going to be somewhere inside. It is also located 2/3 of the way from each vertex. So let's look at that on our diagram. So from the vertex to the centroid is 2/3 of that total distance. So what does that mean about the distance from the centroid to the other side? It's 1/3 of that total distance. So if you are at a vertex, you're going to have to walk 2/3 of the distance to get to the centroid. And if somebody's on the side of the triangle, they're going to walk 1/3 to get to that centroid point. So this is 2/3 of the whole, and this is 1/3 of the whole. Now, we're going to talk about some more problems that deal with those numbers a little bit later, but just keep that in mind. The centroid is also the center of gravity for a triangle. Now, that piece of information is really important when you're talking about artwork. Have you guys ever seen like somebody balance something on the end of a pencil, right? Well, you could balance a triangle on the end of a pencil if you found the centroid. So all you have to do is measure all three sides and find the middle, and then draw a line from the opposite vertex to the middle of that opposite side. And then you found your centroid. So all the little artwork that you've seen, you may have seen sculptures or maybe triangles hanging from a ceiling, and you're wondering like why they're not sideways. That's why. Yep. And so center of gravity for any triangle is your centroid. So hanging that triangle from the ceiling or balancing as a sculpture, artists find the centroid. So who knew that art? It is, yes. And so who knew that math could be so important when it comes to art? All right, let's talk about our next one. The next one is the incenter. Now, the incenter is the point where the three what of a triangle intersect? Angle bisectors. That's right. When we look in that picture, we see all the angles that are split in half. So all of those are angle bisectors. Similar to the centroid, the incenter always falls inside the triangle. So no matter what type of triangle that you have, that incenter is going to be in the middle. It is blank from the sides of the triangle. In that blank, you're going to put equidistant. You remember what equidistant means? The same distance, equal distance, right? So let's look at that in our picture. If that part is true, then we're saying the distance from the incenter to the side is the same. So those three distances that I highlighted, or we could mark them as being the same. Those three lengths from the incenter to the side are going to be the same. Now, since those are the same, then the incenter is the center of a circle that is inscribed by the triangle. What does inscribed mean? Written inside. So that means I can draw a circle. I'm going to do a very bad job of this, but I can, yeah. Let me get that top part a little bit better. But I can draw a circle that is inside of that triangle. Maybe I should fix it to where it looks a bit better. But that circle fits perfectly inside of there. And the reason it does is because these three segments are equal to each other. So what does that mean that this segment is? And this segment, and this segment, it's a what? With that circle, it's a radius. You're exactly right. These three segments are the radius of that circle. So the end center is the center, and the distance from the center to the side is equidistant. So it means it's the radius of that inscribed circle. Now, key thing to think about, and this is what I do with this one, keep those key things together. Inscribed, in center. Those are key parts for this shape. All right, let's move to our next one, which is the circumcenter. What is the circumcenter made up of? Very good, perpendicular bisectors. Remember, a perpendicular makes a 90 degree and a bisector cuts things in half. And we see that on all three of those lines. Again, these are the only ones that do not have to be drawn from a vertex, so they can be written kind of anywhere. Now, the circumcenter falls in different places depending on what kind of triangle it is. So first, the circumcenter will fall inside if the triangle is acute. So just like this triangle over here to the side, that's an acute triangle. We see that circumcenter inside the triangle. It doesn't necessarily mean the center of that triangle, but just somewhere inside, okay? Where do you think it falls when it's obtuse? Outside. And then where would it fall if it is a right triangle? Well, where's the center of a triangle? Let's draw a little right triangle over here to the side. Okay, here's our little right triangle. We said that if we have a circumcenter, it's made up of perpendicular bisectors, right? So perpendicular means 90 degrees. Bisector means cuts it in half. So let's say that I go to this bottom part right here. I'm going to say halfway is about right here, right? Would you guess? And then we find that halfway point and we make a right angle. There we go. Okay, now you might want to turn your paper. Let's do it again with this side here on the left. Find the halfway point. It's about right here. And now when I make a right angle, it's going to be horizontal. The middle of what? It's the middle of the hypotenuse. That's where the circumcenter would be. Because now if I go to this side and I find the middle, that's where they already intersect, and I make a right angle, it's going to go something like this. So it's going to hit at the hypotenuse, and more specifically at the middle. So if you want to put middle or midpoint beside there, that's where it will hit. So if you know what it's made up of, you could visualize it. You could think about where would it be. So perpendicular makes that right angle. Bisector hits it in the middle. So it's going to hit the middle of that hypotenuse. Now, the circumcenter is equidistant from the vertices of the triangle. So now we're kind of going to go backwards. So the distance from the centroid, and I'm going to have to draw some extra lines in here, the distance from the circumcenter, to each side, each vertex is going to be the same. So these three measurements that I've just drawn in will be the same length. So it is also the center of a circle that is, or that circumscribes the triangle. So what does that mean about the circle? It's on the outside. I'm going to have to draw a pretty big circle here, but hey, that was better than my last one. So what does that mean about the distance from the circumcenter to the circle? It's the, not diameter, but radius. It is the radius. So key thing on this one, keep in mind that the circumcenter circumscribes. Just like in-center inscribes, circumcenter circumscribes. All right, we have our last one that we are going to talk about, and that is the orthocenter. So the orthocenter is the point where the three, what's the last one that we hadn't talked about yet? We did angle bisectors. Altitudes, that's the one. Because the altitudes make what? The height, and they make right angles. They make right angles, yep. So all of these have right angles. So similar to the circumcenter, the orthocenter falls blank when the triangle is acute. Where do you think it falls? Inside. Blank when it is obtuse. Outside. Now, where is it going to fall if it's a right triangle? It's not going to be in the same place as the orthocenter. So maybe let's draw a right triangle over here to the side. Now, look back at your right triangle on the front that we did when we did altitudes. Where was the altitude on a right triangle? It was on the side, right? So your altitude for this right triangle is going to be here. Now, if I turned this right triangle, where is it going to be with the base? At the base. So where do they intersect? Oops, now it went backwards. They intersect at the right angle, at the bottom, yep. And so it is on the right angle when it is a right triangle. Because the altitude makes that straight up and down vertical line with your sides. All right, finding the intersection of blank altitudes, we'll find the orthocenter. How many did I have to draw to find the altitude there? 2. So finding the intersection of 2 altitudes, we'll find the orthocenter. And that actually works with any of those different centers that you have there. So we have discussed 4 types of points of concurrency. I'm going to make that really small for a second. We have our centroid, our in-center, our circumcenter, and our orthocenter. Starting today, you need to memorize them and all their facts about them. Okay? So what could be helpful to help you memorize those? Flashcards. You're exactly right. You might want to write centroid on the front, and then on the back you can put medians, always inside, 2/3 from each vertex, center of gravity. Hit those highlight points. That's right. Draw the triangle on the outside too. What else would be good to help you? Writing it down more than once. There's probably, y'all probably used this before. What is the game that you can play with it? Quizlet or something? It's probably a Quizlet. Somebody has probably already made one that you could look at. Or look at, yeah. All right, look back on the front. We have a question for you now. Okay, this is a real world kind of thing. So some of you may be going, when am I going to use this points of concurrency? Well, if you are making some city plans, you might want to use them. So it says, a city plans to build an amphitheater and wants to locate it within easy access of the 3 largest towns in the area as shown on the map. The developer must decide on the best location. The city will also have roads built for access directly to the towns or the existing highways. Describe how the developer might identify the location of the amphitheater, choose one of the methods described, and justify why this is best. So here's what I want you to do for 2 minutes. I want you to look back at these 4 things right here and decide which one of the 4 would be the best. Now, I want you to do this on your own first. No talking to anybody around you. Read through these, read through this again, and decide which one is the best. You got 2 minutes. Okay, now, still without sharing, there are 4 stations in the room. Here we have in-center, circumcenter, orthocenter, centroid. Take your paper with you, get up, go to the one you think it is. So in-center, circumcenter, orthocenter, centroid. Oh. All right. Talk in your group real quick why you think that one's the best. Find a buddy and talk to a buddy. Y'all two talk with each other, a group of 3. Did anybody want to make a change? Everybody wants to stay with their choice. All right, y'all head back to your seats. Let's see what is the correct answer. Discussions are always good. Y'all have some great explanations here. So nobody went to Ortho Center, and I would agree that's not a good choice. Only one went to Centroid. Is that the best choice? Well, now that person is saying no. And I would also agree. When you think about Centroid, remember what we said at the very beginning? It is 2/3 from each vertex. And what are the vertices here? A, B, and C, which are the towns. Do we want to drive further away from town? No. So several of you said in center. Why would in center be the best? Okay, the center is always inside the triangle, and this looks like it would be a bit of an obtuse triangle, right? So it's going to be somewhere inside this triangle, and it's equidistant from the what? What is the in center equidistant from? Is it the vertices? The sides. And the sides are what? The highways. Now, since this one said it's going to have roads that are built from the existing highways, I could consider in center, but a lot of, only a few of you went over to circumcenter, and my guess would be circumcenter. And Tori, you were explaining why circumcenter would be the best. What did you say? That's a good thing to consider. I didn't even consider that. If you have them coming from the highways, you'd have to build some new roads like from those highways, and it would kind of be like you're going halfway down this and then you're going, or you're going halfway here and then going. So you do have a lot of people going from those different areas. Yeah, it looks a little obtuse, but it's okay to build an amphitheater that's outside, right? Because with the circumcenter, it's equidistant from the vertices, like Tori said, and the vertices are the towns. So no matter if you live in town A, B, or C, with a circumcenter, you're always going to drive the same distance. Now, since they mentioned this extra part, they're going to build these extra roads, so equidistance from the highways or the towns would work, but I would probably lean more towards let's drive the same distance from each town. So either one of those work. Mm-hmm. Does that make sense? All right, grab your notebook paper now. Let's do some actual math. All right, so draw this picture and write down those 3 questions there. There is not much work to show with these at all, so you can leave 2 lines of space if you want to between each question. Now, while you're writing this down, I'm just going to talk to you real quick about your homework tonight. If you notice up here on the board, your homework is actually a Google form. And on that Google form, a lot of the questions, the majority of the questions, are questions about the points of concurrency or the 4 segments that you can have in a triangle, such as your median, your altitude, and things like that. So the majority of your homework is multiple choice or matching, or I might give you something like this point of concurrency is equidistant from the vertices, and you would choose circumcenter. Okay, so that's the majority of your homework, so not as much math. So there's actually nothing to turn into the box. You submit the form, and that's your homework. Now, I know this picture might be a little hard to draw, but just try your best to draw those lines in there. Don't forget to put the letters. And I never did lunch counts. So we got French cheese bread, spicy chicken sandwich, or teriyaki beef lo mein. Carter? Lo mein? Huh? Spicy chicken? Izzy? Anybody else want anything? I'll get Aiden when he comes back. Lo mein, like the Chinese noodles. It's basically teriyaki beef with noodles. Hey, Aiden, do you want teriyaki beef lo mein, spicy chicken sandwich, or French cheese bread? Oh, points of concurrency. All right, couple of key things here in this picture. So, first off, it tells us that P is the centroid. So, what is the centroid made up of? Medians, right? And what does a median do? It hits the middle, right? It hits the middle of each side. So if you wanted to go through and label some things, this part is equal to this part's equal to this part, and this part's equal to that part, because the centroid is made up of the medians. There's something else about the centroid, and there was a little magic number in there. What did it say? 2/3. So the distance from the vertex to the centroid is 2/3. Now, I don't know about you, but how many of you like to really deal with fractions? Getting more used to it, but maybe not so much, right? Well, if the distance from the vertex to the centroid is 2/3, the distance from the centroid to the side is 1/3, which means I could take this whole line and split it into 3s. I could split this one here, here, and here, and there's 3 parts. Here we have 2/3, and here we have 1/3, right? So each part is 1/3. So if I know the distance of the whole line, I could split it into 3s. So one little formula you could use, if you have the whole thing, you could divide it by 3, and then that would give us a piece. Now, would it give us this piece that's 2/3 or the piece that's 1/3? It's a piece that's 1/3, and the 1/3 piece is shorter, right? So it gives us that shorter piece, which is the distance from the centroid to the side. So remember, the short piece hits the side. Now, if I know this short piece, what could I do with this short piece to get this longer piece? We could subtract it from the whole, but what if we don't know the whole? We could multiply it by 2, right? Our shorter piece is double. If we double it, we get that longer piece. So the other formula we could do is the short piece times 2 equals the long piece. And the long piece hits the vertex, hits the corner. So if you know those formulas, that can help you find everything that you would need to find in this picture. So let's go through and figure out what we know. That was a big sneeze. All right, so first question says, if CD is 45, so if I travel that distance from C all the way to D, that's 45. Now, what am I going to do with that whole distance? Divide it into 3. So what's 45 divided by 3? Well, what part would be 15? The short piece, which is PD. So PD is 15. How would we get CP? Multiply it by 2. Or, like Dixie said, subtract it. the whole minus that part. What's 45 minus 15? 30, which is the same as 15 times 2. Ta-da! That's a lot easier than using the 2/3, isn't it? All right, so let's try our next one. Our next one says, what if BC is 10? Well, here's BC. That means this side right here, this whole thing, is 10. What does that mean BE is? 5. And EC is? And why are they 5? They're equal to each other because a centroid is made up of medians. And medians cut the side in, there you go, into 2 equal pieces, or half. All right, our last problem here, we're going to be using the same line, so I'm just going to write underneath it. What if PC now is 27? Now, we're going to kind of go backwards. We know which part, the long part is 27. So how am I going to get my short part? Divide it by 2. So what's half of 27? 13.5. So what is 13.5? PD. And CD is the whole thing. So how would we figure out the whole thing? We could add those 2 parts together, or we could also multiply this small part by 3. But what's 13.5 plus 27? 40.5. And then somebody with a calculator real quick, just check. What's 13.5 times 3? 40.5. Ding, 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 ding. So, key thing that you need to remember is these equations. If you got those down, you can find everything that you need about a centroid. Let's do one more. Don't look so excited, everyone. Yes. Yes, you may. We're going to take a brief, hopefully brief intermission to get the next problem. When the next problem comes up, though, I want you guys, oh, there it is. I want you guys to try it on your own. So write down all the questions, though, because when you see this in your notes, you want to know how to do it. I don't want you asking me next week, well, I didn't take very good notes. I feel like I had this conversation with somebody just on Monday. Wonder who it was. Well, I didn't take a very good note, so I don't remember what that was. So take good notes so you remember what to do. All right. And try these with the person at your table. Hayden, you can work with the guys behind you if you need to. But answer the questions, check with the person at your table, see what you got. Would anybody like to come up and explain number 1? Xavier, you want to do number 2? Okay, you got a question. All right, Xavier's going to explain number 1. Everybody listen.
y if YW is 9, find TY and TW. So if YW is the short part, we can multiply that by 2 to get the long part, which is TY, and 9 times 2 equals 18. And to find TW, we have to add all of that together, and 18 plus 9 equals 27. So TY is 18. And TW equals 27.
Very good, yes. And when you have multiple segments, you want to make sure that you label them where it makes sense. You're good. So putting it underneath is fine, and you could also write TY equals like we were trying to do up there, and TW equals, so that way I know which ones you're talking about. Because whatever order you put it in, I'm going to assume that's how they were asked in the question. But if you want to write what they are, then that's good. Who wants to do number 2? Izzy? You want me to hold it for you? Okay. Our interprets while she designs on the board. Y'all don't like to talk on a microphone? Okay, tell us what you're doing, Izzy. I'm going to say it. You tell me, and I'll say it over here. YU equals 9. That's the longer piece. She made an equation, x times 2 equals 9, so you divide it by 2. So 9 divided by 2 is... It's 4.5, which would be CY. Add those two together and you get the total 13.5 for the whole CU. Good job. So yeah, with that piece we were given the long piece, so divide it by 2 to get the short piece, add the short and long together to get the whole. Very good. And I like how you set it up as an equation. You can definitely do that. Who wants to explain our last one? Tori? Come on up, Tori. Tori. Oh, sorry. What color do you like, Tori? Blue. Hold it near you. Oh, no. Okay. I feel like I'm the golf announcer now. She is staring at the problem. Oh, okay. So you have the total. Vx is the total, which is 9. Oh, she is dividing that by 3. So she gets xy is 3 because that is the short piece. And then she's timesing that by 2. And she's putting that YV equals 6. And she is correct. Very good, very good. So if you are given, like in this piece, the x, which is the whole, you divide it by 3 to get the short, times the short by 2, you get your longer piece. And don't forget, it doesn't matter how you label these. So I asked for VY, and she put YV, but that's the same thing, right? Yes, so that's perfect. All right. Tonight for homework again is a Google form. It is on Canvas. So open up Canvas, click on the Google form. Make sure that you answer all the parts. This was written up from last year, so ignore that 3D models because that's not due tomorrow. But there's no work to show or to turn in. Make sure you check your answers after submission and make sure you answer all parts of each question to receive full credit because it may be like the last few that we did where it says find this and this. And remember, if you don't type it in exactly how I do, it will count it wrong, but it doesn't mean that it's wrong. Okay? I will go through and look at the answers. And so it doesn't matter your score, but it does matter if you understand. And start memorizing tonight. If you need to, when you finish this Google form, because you got 30 minutes, a lot of you will probably finish it. So when you finish it, go ahead and make yourself some flashcards. If you need flashcards, let me know.